Good morning and welcome to ILSOY Advisor webinar, Understanding Biologicals for Improved Soybean Management, brought to you by Illinois Soybean Checkoff. I'm Todd Steinacher, Content Coordinator with ILSOY Advisor, and I'll be moderating today's webinar. I want to thank you for taking time out of your busy schedule to join us this morning, and I have a few housekeeping items to begin with. If you are including your CCA number when you register for this webinar and you stay for the entire presentation, your number will automatically be submitted for one CEU in crop management at the conclusion of our webinar. If you're listening to the recording of this webinar, you will need to go to Certified Crop Advisor website, log into your account, and self-report for 1 credit. You can ask questions during our webinar by using the tools panel at the bottom of your screen, and we'll have a Q&A at the end of the presentation. Without further delay, I'd like to introduce today's presenter, Connor Sybil. Connor is a PhD research assistant in the Department of Crop Sciences at the University of Illinois, studying under the advisement of Dr. Fred Below. He is currently in his 3rd year of his PhD program in crop physiology laboratory at the University of Illinois, where he previously received his bachelor's and master's degree in crop science. His research focuses on categorizing biological products and understanding where, how, and why they work to improve fertilizer use efficiencies to increase crop yields. He is also using agronomic inputs and various methods of crop residue management to enhance nutrient release and improvement of soil health. And with that, I'll turn it over to you, Connor.
All right, Todd, thank you very much for the introduction. And as he mentioned, we are talking today on biologicals for improved soybean management. And the reason we're talking about biologicals today, they're not new. They've been around for a couple of years, decades even going back, with different products here and there. But what we've seen recently is an exponential increase in the number of products available and their use being pushed by different retailers, different companies. And it seems like every day there's a new press release about some joint collaborative partnership between biological companies and our cedar fertilizer companies. So there's a lot more information coming out there. And so we're going to try and present some of that, filter through it to give everyone a better understanding of biologicals, what they are, how they work, and how maybe they can be incorporated onto your farm. But before we get right into biologicals, we're going to start a little bit on some background base, setting the stage for soybean management. And we always start with the question, is soybean currently managed adequately? I think of we're in Illinois, Midwest, often referred to as the Corn Belt, not the soybean belt yet, but maybe we'll get there. And so the question of is soybean currently managed adequately is because often growers are really managing corn. We think of soybean as a rotational crop. So are we really achieving the full yield potential of our soybean acres? And what is that full yield potential though? What can we achieve? So I'm going to test your knowledge a little bit and say, what is the world record soybean yield and what is the soybean yield gap? Now you're all off the hook today because if this was in person, I would actually be able to get some of you to force you to answer these questions. But today I'm going to help you out and I'll be answering them for you. And so the world record soybean yield happens to be 190.2 bushels per acre. And that was set in 2019 by Randy Dowdy down in Georgia. And so if that's the world record yield of soybean, what's the average record for the US? Well, that happens to just be 52 bushels per acre. And that was achieved in 2016 and I believe again in 2018. By the way, I have to give a shout out. Illinois record is 64 bushels per acre. And I think that might have something to do with Illinois Soy Advisor helping our growers out. So the yield gap then is that record yield minus the average yield, and that is 138 bushels per acre. The yield gap of what we're currently averaging and what we could average is almost 3 times that of the current average. So there's a lot of potential to get more yield out of our soybean acres. Where is that yield made up? Well, it's a pretty simple algorithm. It's simply the pod number per acre times the seeds per pod times the weight of each individual seed. And if we can increase any one of those 3 factors, then we can see increases in soybean yield. And so we're going to start with some pod number, looking at pod numbers on the soybean plant. And how does pod number really affect soybean grain yield? And so this is a graph here where we look at different pod numbers along each node of the soybean. And on average, we're probably about 2019, 2021 nodes. And in a 50 bushel soybean crop, this is the distribution along the plant where that yield is held. And so you'll see a majority of soybean yield is found somewhere between node 6 and node 16. And that is where we look then, if we're going to increase yields, increase pods per plant, where are we going to add that yield? Is it going to be in the middle, the bottom of the plant, or the top of the plant? Well, if we're going to increase grain yields via better pod production, it's going to be on the lower or upper nodes because the bulk of yield is already set in those middle nodes. And so if we want to get to a 12 bushel response, it's adding more pods to the top or the bottom of the plant. And really, how many pods do we have to add? What is it going to take to see that 12 bushel increase? Well, if you're planting about 140,000 plants per acre, one more pod per plant equates to 2 bushels per acre. So that display there where I show we have a 12 bushel response, that's just 6 more pods per plant. And so it seems pretty easy, right? 1 more pod per plant, 2 bushels. Well, we have to manage the crop to get those additional pods. And so we're going to start with the basics of traditional approaches to soybean management. And these traditional practices, right? First things first, you're selecting your genetics. You got to pick the right variety and the maturity group for your region. Illinois is a long state, so we have quite the range. So in southern Illinois, we're pushing maturity groups of 4, maybe even 5. And in northern Illinois, we're more in that 2 range. What we've found in some of our research that I won't go into today, typically the longer maturity you plant for your area, the higher the yields. But variety selection is the #1 starting point before that seed even goes in the ground. And then you're going to plant. Planting population on soybeans pretty variable. I think most growers fit in the range of 80,000 to 160,000 plants. Some are pushing populations lower and some higher. And traditionally, I think the common method is the later the planting goes, the higher the population we plant. Which also gets us, though, to planting dates. This is something we're seeing a big change in, I think, across acres, where we're pushing soybean planting earlier and earlier. Traditionally, soybean is planted after corn. But now we're finding our soybeans are pretty resilient. They're hardy and they can sit in the ground a little longer and still emerge and yield. So we can get earlier planting dates. And I just have a quick graph here. This is work of Vitor Favaretto, another master's student with Dr. Bilo. And he looked at 8 years of our check plot yields based on planting dates. And what he found is that after April 20th, every day that you delay planting, we lose about 1/2 bushel of our yield potential. So the earlier planting, the higher yield potential. And that has no additional cost. It's just getting the equipment across the fields a little earlier. So earlier planting dates, we can get some higher yields by giving that plant more time to get some sunlight interception, more nodes, more pods. Think about fertility for soybean. Typically, it's leftovers from the previous corn crop. A lot of times we fertilize our corn with P and K fertilizers. We rotate our soybean on. They kind of scavenge what was left or what's being pulled out of the residues. And then when we go to the next year's corn crop, we fertilize again. And then what we're starting to see another increase in is fungicide, insecticide at the R3 growth stage. Not across all acres, but definitely increasing year to year because we want to protect the leaves to make sure we get good seed fill. So these are kind of the standard management practices that we're seeing across broad acres today. And so then we start scratching our heads and think, all right, what's next? How else can we manage soybean? And I think that's why everyone's here today. And that's simply the introduction of biologicals. I get really excited about this, of course, because it's the core of my research, but also because it is new and we are learning a lot and there's a lot more opportunity here than I think we fully have realized yet. And so today, what we're going to focus on for the remainder of the talk is the different biologicals, what they are and how they differ, how they work, which really is the key basis to how then we should use them in our systems, because they're all unique and they can't all be used exactly the same way. So we're going to start that way, though, is how can biologicals be used? Well, the first and easiest for growers is seed treatment, right? Because you have to plant the seed to get a crop, And if that biological is already on the seed, well, then it's a free ride of application. So there's no application costs. And it's putting that biological right where that seed is going to grow. It's placement, making sure it's positioned to benefit the crop. The next opportunity that we can add a biological is in furrow. You think about a starter fertilizer system. I know that starter fertilizer is more common on corn, but if you have that system and it's on your planter, there is opportunity to put liquids in furrow on soybean as well. And so let's add a biological if we're using that system. The other opportunity is foliar vegetative stage, thinking with your post-emergent herbicide pass. Most growers are applying herbicides to their fields, and so you're making the pass. Let's add something to benefit soybean grain yield when we're making that pass already across the field. The next opportunity would be the reproductive stages. And we're thinking fungicide, insecticide timing. As I mentioned, that's growing as a management practice we're seeing more frequently. And so here's a diagram where I have just some examples of visuals of these. So here's that in-furrow system, right? You put in a starter fertilizer with a biostimulant or a biological in the furrow. Here's an example of seed treatment, a lot of different colors. And sometimes that seed is naked, but opportunity here to treat the seed and then use that as the carrier of the biological. This is a picture of corn. I know it's a soybean webinar, but the idea is similar, that post-emergent herbicide application where we have a smaller crop with a lot of soil still exposed. When we think about adding a biological at this stage, you could be targeting the vegetative crop, but you can still be targeting the soil. And that's something we're going to get into later. Some biologicals you need to do early to get soil contact, and they're not as good in the season when you only have foliage present. And that's this last timing, whether it's R3 stage in soybean or tassel in corn, we're often putting a biological out with our fungicide. Key here, it's all vegetative. So make sure that the biological you're using is designed to be targeted for plant leaves. These are the common methods that practices that growers are doing today. So they offer free ride opportunities for biologicals. But now we need to get starting with some innovation. Is there other opportunity to maybe use biologicals? Maybe we coat our fertilizer. I mean, if we're coating our seeds, we can also probably coat our fertilizers, use the fertilizer applications to carry our biologicals to the field. Or crop residues. I mentioned earlier, soybeans typically not fertilized because it scavenges off of last year's corn stover. There are biologicals that are really effective at degrading residues, releasing that nutrient from that previous crop, and therefore you're re-providing that fertilizer for the next crop through residue, which we often refer to as nature's biological, to help feed the next year's crop. And so there's multiple opportunities to use biologicals. But I still haven't answered the question yet. What really are biologicals? So there's three big categories I think almost everyone has heard of. Plant growth regulators, they're pretty common. They've been around. These are the hormone products. Think of things like Ascend or Cygen or Radiate. Plant growth regulators, plant hormones for plant growth. The other categories, and these next two are the ones that are growing the most on industry products, is the beneficial microbes or the biostimulants. And because the plant growth regulators are hormones and they've been around, we're actually going to focus the remainder of the talk on these beneficial microbes and the biostimulants. In summary, you can kind of think of these as the living or the dead, or biostimulants often referred to as more the chemistry side. And so we have the terms biologicals and biostimulants. You've probably all heard these. You're probably wondering what's the difference. Right now, they're kind of used interchangeably, but biologicals often refers to more the livings and then biostimulants more the dead. But regulatory side, these are making it into regulation and legislation. And so the last Farm Bill actually was the first document to have a description for plant biostimulants in government. And what they claim a plant biostimulant is a substance or microorganism, i.e. beneficial microbe, that when applied to seeds, plants, or rhizosphere, stimulates processes to enhance or benefit nutrient uptake, nutrient use efficiency, tolerance to abiotic stress, and crop quality and yield. So this is what these biologicals are supposed to do. So I've answered a little bit about how we're using them and what they're going to do, but I still haven't told you what they really are, right? And there's probably a reason for that, because to me, that's a really stressful question. Here's a younger version of me 4 years ago, starting as a fresh young graduate student with Dr. Bilo. And 4 years later, after biostimulant research, I'm not sure if that hair loss is because I'm a little older or it's a stressful question trying to understand these biologicals. But I am happy to report now that 2021 is here, we do start to understand that. And I think my hair is coming back. And that's because biologicals have subcategories. And here is a list of 7 of the most common types of biologicals that you'll see on the market today. This is not an all-inclusive list. There are other types of biologicals out there. These are definitely the most common and the ones that are most abundant in commercial products. And this is where we can separate the top 3 there as our beneficial microbes and the bottom 4 as our biostimulants. And so we're going to go through these one by one to really understand how each one is individual, how it's supposed to work for our crop. So that way, when we think about managing our soybean, we can choose the right category to get the job done. So starting right off the bat with the nitrogen fixing bacteria. And we're starting with these because they're pretty well known for soybean management. But what nitrogen fixing bacteria do is they pull nitrogen out of the air and convert it into a plant usable form. And as I mentioned in soybean, we know this. Soybean and rhizobium bacteria have a relationship, a synergy. They work together because they're partners. And this is a picture of a soybean root. I think many of us have seen these before. Agronomists always love to dig up our roots, right? And these little guys here, these are soybean nodules. And that is holding that rhizobium bacteria in the root zone. And that's a synergy. As I mentioned, those bacteria take the atmospheric nitrogen, N2, plants can't use it. But the bacteria can convert that to a plant usable form, ammonia, which is then transferred to ammonium and plant uptake. In exchange, the plant says, I can give you some sugars. So it's a good relationship, one that's well known, and probably the first big biological use in soybean production is as a seed inoculation. I think there's a lot of this going on in acres currently, and this is kind of where biologicals in soybean got started. Use of inoculating bradyrhizobium into soybean fields. So if this biological category is providing nitrogen for the crop, I have a question for you. How much nitrogen do soybean plants need to accumulate for each bushel of grain? I'm going to give you a few seconds to think on that, and then I'll answer it for you. So for each bushel of soybean grain, we need 4 to 5 pounds of nitrogen. That's a lot. Soybean has a high nitrogen requirement. Think of corn, it's more around that 1 pound mark. And so that's a lot of nitrogen. And we know that we're getting some from those nodules, that relationship. But the rest of it has to come from 2 other sources, either fertilizer or the soil through organic matter mineralization. And we know we're not typically fertilizing soybeans with nitrogen. So there's a lot of nitrogen that they have to pull from the air or out of the soil. And I'm going to take you back. What was that world record soybean yield again? I think it was 190 bushels. So if you do that math at 4.5 pounds of N per bushel, the world record soybean yield required 855 pounds of nitrogen per acre. That's a lot of nitrogen. And how are we going to supply that to make sure that we can achieve those high yields? Well, we know the nodules, right? So how much soybean nitrogen comes from those nodules? Well, it's about half or 50% in the US. Down in Brazil, South America, that is more closer to 70%. They have a really good efficacy with inoculations, and they have lower organic matter soils, so less soil supplied in, so they get a little higher from their atmosphere. But in the US, 50% of that soybean's nitrogen is coming from those nodules. So now we have to start scratching our head. How are we going to get to those higher end requirements for higher yields? Is there other opportunity to enhance nitrogen fixation in our soybean crops? So sticking to those nitrogen fixing bacteria, but thinking a little differently. There are non-rhizobium microbes. They colonize along the roots, not in a nodule, or they can even colonize inside the leaves, and they provide supplemental nitrogen. Some products you've probably heard about and seen on the market, Pivot Bio's Proven. This has been edited to continually fix nitrogen right in the root zone. And so it's a different source of biological nitrogen fixation to provide nitrogen to soybean. And this one is another product I think many growers have heard about, is Invita. And what's interesting about this is it colonizes inside the cells of the roots and the leaves. And so what's cool about this is you can actually apply that one foliar. So now we have different placement opportunities for nitrogen fixing bacteria. And I think some of you may be scratching your heads right now and saying, well, yeah, I heard about those, but those are corn products. Well, that's where they started. But I'm a research student, and we're always looking at the next step. And the next step might be these types of products for soybean management. And so I'm going to highlight a quick study we did last year. This is also Peter Favaretto, our soybean graduate student, where we looked at these novel nitrogen fixing products for soybean. And that proven, as I mentioned, we put in furrow, and we can put that in Vita in furrow. But in Vita also can colonize the leaves. So we tried a foliar. And what did we see with that? Well, the in furrow proven gave us almost a 3 bushel response. And in today's market, that's a good ROI. The in furrow and Vita, that gave us almost 2 bushels. So we're still in positive direction and still a positive ROI. And then that foliar application was a similar response, about 2 bushel response. So the key thing with the nitrogen fixing bacteria, we know about their traditional use in soybean, but let's think a little bit outside the box. And that biologically fixed nitrogen from a product or an inoculation can increase soybean grain yields. And there's new and innovative biologicals that can provide alternative approaches to N fixation in soybean. What this does is opens the space for seed treatment. I did not mention this. The challenge with seed treatment is I'll call that crowded real estate. How many different products can we coat on that seed before they're all 100% efficacy, right? At some point, some of those products may be not as effective when we coat too many things. So if we can get our nitrogen fixation to soybean through in furrow or foliar, now we've opened some space up on the seed, and I'll tell you why that's important in a little bit. So that's nitrogen fixing bacteria. The next category of biologicals that we see out on the market is these phosphorus solubilizing bacteria. What they do is they increase the availability of mineral phosphorus. How do they do that though? Well, we know that phosphorus is pretty well abundant in a lot of our Illinois soils, rich organic matter soils. And so there's phosphorus there, but the challenge is it has to be plant available. And in our soils, phosphorus is often tied up with cations like aluminum or calcium. Calcium phosphate, aluminum phosphate, it's not plant usable. But what these bacteria do, when you add them to the soil, it's these yellow guys here, a little simple depiction. Well, they secrete organic acids. And those organic acids help separate these insoluble phosphates and make them plant available. So we have unavailable phosphorus, we add our solubilizing bacteria, and lo and behold, now that phosphorus is available for crop uptake and use. Just from the soil, no fertilizer used here. So when we think about phosphorus solubilizing bacteria, if you want to incorporate this into your system, there's a few considerations. You really want to optimize grain yield with soil contact near that growing root, because once that phosphorus is released, well, it can get tied back up. But if you inoculate or do an in-furrow, putting that phosphorus solubilizer right in the root zone, the second they free that phosphorus up, it can be given to the plant for uptake. So that's one consideration with these types of products, soil contact. And the other thing is they're living microbes. And when we think about living microbes, they colonize the root zone and they live all season long. If we think about a fertilizer application, right? Maybe we put it all upfront broadcast or even in the last fall. How much of that phosphorus is still there later in the season? Because late season phosphorus is really important for soybean, and I think we often overlook it. And this is the uptake graph of phosphorus for soybean for 60 bushel soybean. And so what you can see here is that a 60 bushel crop needs about 40 pounds of P2O5 per acre. And what's also interesting is we have rapid uptake. You can see here, this line is almost, it's 45-degree angle. There's a lot of uptake every single day for 70 days, right? From about 40 days to 110, rapid phosphorus uptake. And 45% of that is during grain fill, right? We're entering that stage now as we enter our earlier planted beans, R3, and then we get into August in the grain fill. Now, if all of our phosphorus was put out in April or May, and we need 45% of that P in July and August, well, the phosphorus solubilizing bacteria that are living in the root all season long can keep feeding that crop phosphorus. That's how we're going to optimize grain fill. One of those three components to yield I mentioned was seed weight. Well, we can improve seed weight by making sure we have the phosphorus available to fill those seeds. So just some key takeaways in phosphorus solubilizing bacteria, how they work, and how they can benefit our grain yields. The next and last big beneficial microbe is the mycorrhizal fungi. And what these do is extend the root system of the crop. And they are fungi, are microorganisms. Think of yeast, molds, or mushrooms. And in particular to our cropping systems, we think about our arbuscular mycorrhizal fungi, AMF. And so what these do is increase the root surface area through a symbiotic relationship. And so in this little simple depiction, you have a dicot broadleaf plant or a grass crop. The orange or the yellow is those crops' natural roots, and the black is that AMF fungi. And just picture that diagram. Remove all the black lines. There's a lot less there. What this does is it improves soil contact. And you think about water uptake or immobile nutrients like phosphorus. The more soil we can get those roots in contact with, the better access they're going to have to those different nutrients and water. And so it's increasing surface area of the roots, helping us better get access to our soil, soil nutrients and other aspects with water. So key takeaways when I think about arbuscular mycorrhizal fungi. Seed inoculation is probably going to give you the greatest potential because they grow with the root. And if that AMF is with that seed from the start, as the root emerges and the root grows, well, that AMF is going to colonize right along with it. So this is one thing when we talk about biologicals. It's not just grabbing the product and using it, but it's knowing how to properly place it to ensure we get success. And I mentioned earlier, if we're traditionally using that seed treatment for a nitrogen fixing bacteria, well, if we can find a new way to apply that nitrogen fixing bacteria, we've opened the seed space and now we can inoculate with something like AMF. And I will just mention briefly, the source of the inoculum can impact the efficacy based on your environment. There's a lot of different environments, different types of AMF, and they're adapted to maybe Southern Illinois versus Northern Illinois. So just keep that in mind that certain AMF may be better in certain environments. So that wraps up the three categories of the beneficial microbes. Now we transition into the biostimulants. The first one I'm going to talk about is enzymes. And these are really, really cool and really, really new. Probably the newest category to emerge on the market side. And in particular, we're going to focus today on phosphatases because these are the most common ones I've seen in commercial available products. What's interesting about enzymes, though, is they're increasing the availability of organic phosphorus. Earlier, see above here, I talked about mineral phosphorus. This is a different pool, organic phosphorus. How do they do that, though? Well, there is organic phosphorus, as I mentioned earlier, was bound to other cations, but it can also be composed inside of organic matter and tied up as organic matter. Think about those residues. Well, what that phosphatase enzyme does is it grabs onto that phosphorus organic matter bond and it releases it and breaks it apart. And so now we have gone from plant unavailable to plant available with that freed up phosphate. And then, though, the question we have to get is phosphatase, are they all the same? And so these are just three example products that are on market. So Brandt has ends up zinc, CHS has an enzyme product, and then Helena has Zypro. And these are the three active ingredients that they put on their labels. So they're all phosphatases, but we have a lipase, a phosphatase, and a phospholipase C. If you're looking at the label, those are the active ingredients. So what we want to know is where are these enzymes acting on our soil organic matter to make that phosphorus available? And that's what this diagram is, a little bit of chemistry. I am on campus today, so we'll give a little bit of a university chemistry lesson. This is organic matter, and in that organic matter, there is phosphorus. And there's different bonds that we can cut to break that organic matter off, cycle that organic matter, and release things like phosphorus. And that's what this phospholipase C does. It cuts the bond right here. Now that phosphorus is available. But if you cut up here or up here, you are degrading residue, but you're not releasing the phosphorus. So just a consideration to think, And these two, I have question marks because they could also be phospholipase C. It's just the generic terms for phosphorus enzymes. And as these products continue to come out on the market, I think we'll see some more consistency in how they label their active ingredients. So phosphatases increase access to organic soil phosphorus. They're not all the same, and each one kind of varies in how it attacks that residue. So just something to keep in mind as you look at different products. And there are variations in soil environment based on the native P levels. What type of organic matter do you have, right? Are you following corn stover? Are you following maybe a previous alfalfa field? Manure has a lot of phosphorus in it, but that's through phytase. So, maybe you want a phosphatase enzyme designed to go after manured phosphorus. So just some considerations in this new category of biologicals, but a really exciting category, I think, because there's a lot of opportunity here. And that's where I come up with biological synergy. And we're going to take a sidestep here and combine these things. So I talked about phosphorus solubilizing microbes. They increase mineral phosphorus availability. Well, these enzymes increase organic phosphorus availability. Now we have two different biological categories, increasing availability of two different phosphorus pools. They're not competing with each other. So now we're providing soil phosphorus for a crop, being soybean, that we typically don't fertilize with phosphorus. And so here's just a really good chance where two different biologicals can be added to the system with a free ride and increase phosphorus availability, high requirement for soybean, and we don't have to maybe use fertilizer. Enhance the cycling of our soils to release that phosphorus and keep it available for crop uptake. Just some considerations on phosphorus and biological categories. The next one that we're going to talk about is humic and fulvic acids. I think these have been around quite a while, and I think a lot of growers are familiar with them. And these do things like chelate soil cations or feed microbes. So here's the chemical structures of them. And so you can see humic acid molecules are relatively bigger and fulvic acid molecules are smaller. But what they have is these functional groups, these guys right here, these carboxylic acids. And that hydrogen gets knocked off and you get this negative charge on there. What that can do is chelate our cations. Now, if you remember from my earlier part of the presentation, calcium and aluminum, they bind with phosphorus. But if you can chelate those cations, you can keep phosphorus available. And by the way, if you chelate zinc temporarily, maybe later in the season when zinc is needed by the crop, it re-releases it. And so you're sort of indirectly providing both phosphorus and a micronutrient with zinc. So there's some beneficial effects there of the chelation properties of humic and fulvic acids. And then the other thing, these rings here, well, what those rings are is carbon. It's just carbon, and carbon content feeds soil microbes, stimulates the root zone. So at the same time, we're also going to help feed the soil microbes. And just a few example products you've probably seen on the market. Hydrohume is by Helena. That's one of the leading, I think, humic acids in the US. And so when you see these products now, I think hopefully you have a better idea of what they're supposed to do for our system and how we maybe target and position them. An important thing with humic and fulvic acids, they act on the soils, whether soil nutrition or soil microbes. So think earlier applications around planting time. And we did a study with that where we looked at either in furrow or soil broadcast, fulvic or humic acid. This is our untreated control yield, 53.5 bushels last year. And when we put that in furrow fulvic acid, we didn't see a yield bump, slightly backwards. And maybe, that in furrow was a little too concentrated, right? But when we broadcast, we got almost a 2 bushel response because we broadcast across the soil and then planted, and we stimulated that soil environment to benefit crop growth. The humic acid, we had about a bushel response for the in furrow and the soil broadcast. I'm a student, and our advisors and committee members always want statistical significance, but think about today's market. 2 bushels be about $30 to the acre, and these products cost $8 to $12 to the acre. And in furrow is either with the planter or that soil broadcast is with your pre-emergence herbicides. It's no application cost. So 2 bushel response in soybean is actually return on investment for these types of humic and fulvic acids at planting. And so just to highlight there, almost a 2 bushel response. And how did we get this? Well, when it was out in the field, you can see here, we had better row closure, and that was due to slightly bigger leaves. We stimulated the root zone. We had bigger, better, happier, healthier plants. And then as those plants grew, that translated to increased grain yields. So key takeaways of humic and fulvic acids. They can benefit soybean grain yields, and they do this by interacting with soil nutrients and microbial communities. And that leads to larger leaves, quicker row closure to optimize sunlight interception for better yields. Biggest thing here is soil supply. These are not going to be products we think about to add to our fungicide applications at R3. These are early season biologicals. That gives me to the last two categories. These are the marine extracts or sugars. And I have these together because they kind of do similar things. When we apply them to the soil, they can stimulate microbes and roots. There is some growth regulator effect with some marine extracts and sugars. But if we do it foliar, typically these are going to be mitigation of drought stress. And what they do as a foliar is they help signal the plant to retain some of that water. So starting with the marine extracts, like I mentioned, they can be soil or foliar applied. And it's a plant health play, really, is what we're talking about. They sourced from algae or seaweed or kelp, oceanic plants. The most common one is this Ascophyllum notisum, the brown seaweed. And I put that on there because if you're looking at the jug, that is what the active ingredient is going to say. So if you're looking at a product and you see this scientific name of Ascophyllum notisum, it's a seaweed extract product. Others are red or green algae. And here's just an interesting thing. The red and green algae are actually often used in human and animal supplements. And so when we're thinking about why we're using marine extracts into our cropping systems, and they're even similar products that humans and animals use, that's because these contain many different biomolecules. They have amino acids, they have carbohydrates like sugars, they have plant hormones, and they have vitamins or antioxidants. Just like when we think about our own health, things that we need, the plants also need too. And that's what these marine extracts are able to provide when we use them in our fields. So how are they working? Well, as I mentioned, there's a lot of different compounds in there. So there's a lot of potential possibility on how we're influencing the crop. And I'll be honest with you, in a field scenario, it is pretty much impossible to know which component of that marine extract caused the response. Was it the plant hormone in there? Was it the sugar? Was it the amino acid? Every situation is going to be a little bit unique. But in general, what we can think about, especially if we're doing the soil application, it's kind of like an espresso shot. When we put it in the soil or if we put it on the plant, it just kickstarts the whole system like that coffee on a Monday morning. And so that's the benefit to these marine extracts is there's a lot of different compounds, so there's a lot of different opportunities to take advantage of. But stimulating root microbiome and stimulating plant health. Here's just an example. Acadian Plant Health is out of, I believe, Canada, and they have a product called Toggle. I believe Winfield distributes this, but here right now I have the example. Ascophyllum notisum, as I mentioned, probably the most common species being used to make these products. So just an example product is something that many growers have probably seen. I don't have yield on it today in the interest of time, but I did a lot of work with marine extracts. And we see anywhere from 1.5 to 2.5 bushel response on average. And sometimes it's greater than that. And we didn't see backwards too often either. So we have seen good positive responses, but the important thing, that was a foliar response. And now we're starting to look at soils. So the key takeaway with the marine extracts, they're complex blend of metabolites, which gives you versatility in how they may be used. Foliar, it's typically going to be drought stressed by regulating the water use. They help the plant signal we need to hold on to our water, improve plant health, and therefore sustain yield under stressful conditions. If we're doing the soil, there's a lot of carbon in there too. They're stimulating the microbes. They're giving improved rhizosphere, kind of like those visual responses I showed with the humic acids, right? Bigger, happier, healthier plants because they had a better stimulated root zone. And the final category that I have for you is the sugars. And these can again be soil or foliar applied, plant health aspect. What are sugars? I think many of us know sugars in general, but we're going to get a little more deeper into their chemistry today. So they have carbon, oxygen, or hydrogen. They can be individual units, sometimes referred to as monosaccharide. They can come in pairs as a disaccharide or chains, a polysaccharide. And what these do for our cropping systems is if we put them on the soil, they're direct energy source for soil microbes. And we can think right now, I have a Coke here. What's in here? Sugar. I like sugar. Gives me, it gets me up in the morning, Microbes, it's the same thing. Give them a little sugar, and they're going to activate, get that high energy, and they're going to stimulate that root zone. Their sugar, though, is also a signal molecule in plants. And what we do when we foliar apply, we're helping stimulate that plant. And what we see is sometimes a stay green effect. It's a plant health. It's improving plant health through a foliar stimulation. And so here's the chemistry lesson, second one of the day. Here's just what these sugars look like at a chemical level. And so these are the monosaccharides of glucose or fructose. Sucrose here is a disaccharide, and now we have a chain of amylose. And so there's all that high carbon the microbes go after. They start breaking that apart, and they start to get stimulated in the root zone. So that's a quick overview of the major categories. Wanted to try and give you some information about how they work and what is really being targeted with these products. And when I think about biologicals, I think the traditional view, right? We are going to increase grain yield, we're going to get greater nutrient uptake, and we're going to improve fertilizer use efficiency. And I can tell you in our research, we are seeing this, particularly around phosphorus. Biologicals, when added to management systems, we are seeing are improving phosphorus and nitrogen uptake into our crops, and we're getting some higher yields out of that. But what we want to know is, what else are we missing? Is there something else that these products could maybe benefit to our fields? And that's where I come up with the question, are biologicals a tool for soil health? And the reason I phrase it this way, and I mention it, a lot of times during my presentation, I mentioned that these biologicals are stimulating the soil microbes. They're helping accelerate residue and organic matter turnover. Those humic acids, that's the active ingredient of organic matter, right? Anything that we're doing to influence the microbes and organic matter is improving productivity of our soil. It's a better, healthier soil. So maybe that's an alternative perspective to biologicals that we can think of. And I just have an example from our research because I know soil health is starting to show up in soil test packages. So you need to kind of know, why are we testing for these things, and what is it that the soil testing packages are measuring for us? And so the USDA has these soil quality indicators for soil health. And one of those is soil enzymes. And one in particular is this beta-glucosidase, which is it's an enzyme that goes after carbon compounds, and it's really going after organic matter decomposition. And so it's an enzyme that kind of measures soil quality because it's an indicator of organic matter turnover. And so we did a study last year where we looked at in-furrow biologicals and see what is their influence on this enzyme. And we have a microbial blend, a marine extract, or a phosphorus solubilizer. And this is just the activity. If you do take that soil test, this may be what you see on there. It's an enzyme activity. But what we want to look at is the difference from where we didn't apply it. And at 3 days, it's kind of random. There's not much going on immediately. But at 22 days later, or 3 weeks after we applied these biologicals, we had higher levels of this carbon enzyme. So these biologicals are accelerating organic matter turnover. And that's going to give us a more productive field and soil environment for those roots to give us that better nutrient uptake and yields. So a quick summary of the biologicals. They can be effective at increasing grain yields, but the efficacy depends upon the product utilized, the placement of that product, and the timing. Think back to those nitrogen fixers, right? I mentioned one of them, it lives along the root. The other can be applied on the leaves. So both end fixers, but two different placements for those products. And to optimize the benefit is simply understand the product of interest, how it works, and where you want to fit that into your system. Because while biologicals are similar, even within category, there can be a lot of diverse products. Think of those enzymes. And so just understand the product of interest to optimize the performance across your environments and your fields. Our perspective, the crop physiology lab, is just understand what they do and know how they work before you try it. And know that they're not going to replace good crop management. That's why I started this presentation with basic crop soybean management, because those have to still be in play. Biologicals are not going to replace good management. They're going to make good management turn into great yields. And so consider, maybe we're looking beyond grain yield as well. Maybe these are soil health tools that we can also use for long-term benefits in our fields. And the best chance of success is to simply know your starting point. What do you want to achieve with your growing system? What is your goal? And then choose the right biological that fits your goal to get to the successful implementation of a new biological on your farm. That's all I have for today. Thank you very much to Illinois Soybean Association, Illinois Soy Advisor, for the opportunity to speak today.
Thank you, Connor. Great information there. I do have some questions that have been coming in, and I'll just kind of go through them and you can address them to the best that you can. One question, can sugars be utilized to help nodules restart after the recent weather / flooding areas?
That's a great question, and one that actually came up in conversation yesterday with some of our students. I can't honestly tell you yes or no, but when you think about plant production, yes, we do know that when that plant starts to photosynthesize again, it supplies sugars to the roots and the nodules do come back. I don't know exactly what an external applied sugar would do, because when you think about those nodules, that sugar's coming through the root, and if we apply a sugar, it's maybe coming from the outside of the root. But I think there's potential. The challenge is getting the sugar to the roots. So in season, how are you going to get that sugar to the root zone without disturbing and breaking up the roots too much? So a great idea. We'd have to work out some plays, maybe a Y drop to work that sugar down into the root zone. A placement would be the challenge there.
Thanks, Connor. Question number 2, as it relates to the PGRs, what are the best PGRs?
Yep. So the best PGRs is best summarized by saying what are the most common, because you'll see that there are repeat in a lot of the products. Cytokinins, gibberellic acids, and auxins are the 3 most common. Each company has their different formulation within individual products, but those are the 3 growth promoting hormones. And so those are the ones that we find have success in improving plant growth. So auxins, cytokinins, and gibberellic acids. Some newer ones you may start to hear about are strigolactones. They're not as common, but as this area develops, keep an eye out for those. They stimulate root communication with soil microbes.
Great. Our next question is, there's claims that humic acid increases a soil's carbon sequestration capacity. How do you feel about that?
Yeah, so this is a challenge too with humic and fulvic acids. There's a lot of different types. So I'll keep it brief, but if you have liquids in furrow, it's a low use rate, right? You can only put so much out with the planter. But there's some dry humics that you can apply at rates of hundreds of pounds per acre. So let's just keep that in our back mind, is how much humic and fulvic acid. Where that can come into play though for carbon sequestration, humic acids are charged. They can help build aggregates. And when you build a soil aggregate, you can sometimes trap organic matter and protect it from degradation. So in theory, yes, humic acids can improve carbon sequestration because as they form aggregates, that protects the organic matter and keeps it more stable for a longer duration of time. But it's going to come down to how localized and how much humic acid can we feasibly put out into a field.
Great. So our next question is from an inoculant standpoint. There's inoculants that can go in the planter box as we're getting ready to plant, and there's seed treatments that have different days of when it can be applied. What's your thoughts on the ones that can be applied, I'll say, further out from a seed treatment versus what goes in the box right ahead of planting?
Yep. So one of the biggest concerns as well, if we think seed treatment, how long from treatment to the field, right? If we treat the beans and it gets wet and they sit in the box or the planter for 2 weeks before we can put them in the ground, maybe that seed treatment has started to degrade a little bit. But the biggest thing is we think maybe, beyond the seed treatment, these in-season applications, biggest challenge, they need to get to the root. And so the in-furrow options are nice because you're dribbling along the furrow. The foliar, like that Invita that can go through the leaves, that's a new opportunity that's definitely going to grow of interest. But biggest thing about, when you step away from seed or furrow application, we have to make sure we can get that inoculant to the roots. And that's going to be the key to making sure it's successful.
Great. So like many other products, there's variability from field to field. As you look at any of these biological pieces, do you see a lot of variability from field to field, or what situations would favor having some type of biological out there?
Yeah, that's a great question because yes, in my own research, there is a lot of variability across field. A lot of these products help cycle organic matter. And if you have a 6% soil versus 2% soil, maybe there's a difference there. In general, what we see is they're going to help stabilize variability across a field. And that's, I think, where the biggest improvements are. We're going to slightly bring that average yield up by stabilizing different yield environments within a field. As far as comparing field to field, my honest opinion, it's going to be a trial and error. Try to, understand your soils and understand the products. Try and do all the research you can to give yourself the best starting point. But it's going to take a little bit of give and take to incorporate a new management practice into your system. That's one of the things I'll leave with biologicals as well. Sometimes they get tried one year and there's no response, maybe slightly backwards, and there's a lot of confusion and I'm going to walk away. It's a new management practice. So it takes a little time to fit that new management practice into your grower system, in your fields, and that's going to be independent and individual based on the farm and the location.
So the next question is kind of similar to, I guess, linking it up with cover crops. One of the values of cover crops, not only weed suppression, but soil health, it can release more nutrients. So it compared to a biological, do you think the release is similar, or should somebody pick one or the other?
Yep. So I believe you're talking release of nutrition from organic matter, and when we put a cover crop out, we're keeping soil cover, so protecting our soils, but at the same time another burst of biomass. I don't know right now if I would say they compete. I think there's probably a lot of potential to synergy. One of the things with cover crops, if we think in the spring, a lot more residue that we have to manage as well. To get the planter through, get a good stand. And maybe there's a synergy opportunity, biologicals, to help get that cover crop degrading a little quicker in our fields over the winter so we can get a better planter pass. I wouldn't say they're competing at the moment. I think it's two different approaches. And I think, again, it's going to be individual on the system and making that work together. But a great question, a great consideration as we get better at understanding these products. We need to start thinking beyond just in-season use for row crops. Is there a cover crop advantage, disadvantage, synergy, things of that nature?
Thanks, Connor. Another one kind of takes us down maybe a slightly different path. By having some of these biologicals in the soil, we're having things released more timely throughout the season. What's a potential negative to this reaction?
Yep. So the negative, from the ecology perspective, people want to know, how does this influence the native soil microbiome if we introduce a foreign inoculant that's not, used to that field? But I think what we're doing is we're accelerating the system a little bit and helping it along. So I think we're more positive than any negatives. And I think a lot of that is yet to be fully realized. It's as these practices increase in use and increase in acreage, we're going to learn more and understand more, and we'll certainly be looking at that down the road. But the biggest questions on potential negatives is, how does that influence the native soil microbes? Does it change the community structure? And as of right now, we don't really know.
No, thank you. The next one is, how do you sort through a lot of the confusion in the marketplace with a lot of these new products and really separate what has agronomic merit versus what may be a snake oil?
Yep. A lot of it comes down to is knowing the basics behind it. Look beyond the trade name, look at that active ingredient in the jug. Do some research, but like I mentioned, the species of marine extract, that Ascophyllum notisum, that's been proven in a lot of products, and that's an active ingredient that we see good success with. If it's a seaweed species you've never heard of, maybe do a little research and try and look into it before just trying it right away. But the biggest thing is, like I mentioned, is look at what that product is, talk to the rep and see, how knowledgeable are they? Do they really understand the product? And if there's a good understanding of what's in the product, how it works, and you have the right position for it, I think there's worth trying. But just important to know, like I mentioned, humic, fulvic acids. If somebody says spray those on at R3, I maybe question that because it's a soil target.
No, great. To go kind of along with that, a lot of products coming out of the marketplace. Are these companies doing a lot of aggressive testing on the backside that can help support this, or is the testing pretty minimal?
Yep. So I can tell you the amount of research going into these products is increasing very much. as somebody who's working on these research, we get opportunity to try new projects all the time because companies are wanting that background. And so there is a lot of research going into it, and that research is increasing every year from my personal experience. And so I believe, yes, that question probably in the past, maybe not as much research, or there was some companies that were really doing the research, but some that weren't. I think now today that has changed, and every year we're getting much, much more research focused in this area. And so there is sound science coming behind these newer products.
Great. You know, from the university standpoint, whether it be U of I or other academia pieces, what's your guys' future looking like as far as conducting a series of structured tests to basically evaluate the different groupings of the biologicals? Very similar how the university's done, you know, hybrid evaluations or variety trials, just to have more unbiased data and information to the public.
Yeah, so our research group, I can speak directly towards, we're looking at that. Your hybrid example was great. We have a study that I did the last 2 years that'll be coming out, but we looked at 21 products, 3 per category for that exact reason. Let's look at these categories and not just one product per, but a representative. And we looked at nutrient uptake with and without fertilizers to understand which categories are influencing which nutrients so we can make the right pairing down the road, knowing which one to pair with our phosphorus fertilizer or which one to pair with potassium fertilizer. So grouping them and then looking at things like fertilizer influence. The next steps as well are long-term management. Like you mentioned the question earlier, what could be the long-term effects? Static plot is the next step. Repeat applications of humic acids in our residues studies, things like that nature. That'll be the next steps, is looking at more long-term research as well as comparing efficacy of different types of categories.
Thanks, Connor. With that, that's you know, the last questions we have. And it also concludes the webinar on understanding biologicals for improved soybean management. Please take a few moments after the webinar to answer our post-event survey. You can view the recording of this presentation on the checkoff-funded website, ilsoyadvisor.com. With that, thank you, and thank you, Connor, and everybody for attending.
Thank you for having me.